Right. Hello, everyone. My name is Kyumin Kim, and for my open school lecture, I'll be talking about the life cycle of massive stars. So quickly going over the table of contents, I'll be covering five main topics. So life cycle.
규민아, 미안한데,
네네.
주최
네.
측의 방송 사고로 인해서 처음부터 다시 한번 하자.
네, 알겠습니다. 시작하면 될까요?
네, 하세요.
네. Hello, everyone. My name is Kyumin Kim, and for my school lecture, I'll be talking about the life cycle of massive stars. So quickly going over the table of contents, I'll be talking about the life cycle, birth, life, death, and the rebirth of massive stars. So if we look at the overall life cycle of a star, you can see in the first column where it says birth is a linear progression, but then from the second category called main sequence, it divides into two lanes. So one for low and medium mass stars and a different lane for high mass / massive stars. Uh, Depending on the mass of stars, their futures and their evolution are wildly different. So for my presentation, I will be mainly focusing on high mass / massive stars and their evolution. To begin, so what are stars made from? Well, the quick answer is that they're made from molecular clouds, which are large clouds of gas and dust in which stars are born from. So molecular clouds can range from 1,000 to 10 million times the mass of our own sun and can span as much as hundreds of light years. And the picture on the right you can see is a picture of the pillars of creation, which are clusters of molecular clouds. So the materials that are needed for stars to be born are gathered in a structure that we named the pillars of creation. So as clumps of molecular clouds collide with each other and collect more matter, their gravitational force and mass will increase to the point that it starts to collapse into itself. And eventually it will heat up and continue to collapse, creating what's called a protostar, also known as a baby star. So a star is born, but what are protostars? They're a very young star that is in the earliest phase of stellar evolution. So this phase begins when the gravity of the molecular cloud fragment forms a pressure-supported core in the inside. So eventually the star's core squeezes the nuclei of hydrogen atoms together so that it can form helium in a process called nuclear fusion, which many of you might have heard of. So the energy produced from nuclear fusion is able to heat up the star and prevents it from collapsing any further so that it can become what's named a main sequence star. So a main sequence star is a star just like our suns that is able to convert hydrogen into helium in a process called nuclear fusion and maintain balance. So this is the longest phase of a star's life. The star's luminosity, size, and temperature and other characteristics will slowly start to change over the millions or billions of years during this phase. However, main sequence stars, their sizes and masses vary wildly, depending on how big or large their molecular clouds were before. So the size of main sequence stars are measured using a unit of mass called the solar mass, which is labeled with a M and a circle on the bottom. And stars are categorized based on their unit measurements. So one solar mass is approximately equal to 2 times the 10 to the power of 30 kilograms, which is actually very close to the actual mass of our sun. So the mass of our sun becomes the, I guess, unit of measurement for other stars. Now, I said that sizes and masses of stars vary wildly, but then what are the largest ones? So there are stars in the category called massive / supergiant stars, which are stars in the main sequence phase that are more than 9 solar masses. So 9 times the mass of our sun. So massive stars burn fuel at a much higher rate compared to lower mass stars. And due to that characteristic, when helium is exhausted at the core of a main sequence supergiant star, it contracts and the temperature and pressure both rise enough to be able to fuse into carbon. So while other lower to medium mass stars will finish their nuclear fusion when it fuses helium, for massive stars, it continues for carbon and all the way through neon, oxygen, silicon, all the way up to iron fusion. Now, iron fusion is the final stage of nuclear fusion for massive stars. However, the reason behind that is because iron nuclei are so tightly bound that any heavier nuclei and any fusion beyond that does not produce extra net energy. So the star is unable to fuse into other elements that are heavier. So eventually the star will begin to die. But the main interesting point about massive stars and how they die is that they go out with a boom. In a yeah, they go out with a boom in a what's called a supernova. And a supernova, as many of you might know, is an explosion formed by the sudden collapse of massive stars. So when the ion core of massive stars reach a certain size, that's around more than 1.4 solar masses, it is at a point that it can no longer support its own mass, and the core will finally collapse, which will produce an explosion we call a supernova. So a main characteristic and probably the most important part about supernovas are that they're so powerful that during its explosion, it can induce fusion reactions to create new atomic nuclei and birth elements that are heavier than iron. So as I said before, before a supernova, a massive star can only fuse all the way up to iron because it lacks any more energy to fuse beyond that. However, during a supernova, the sudden explosion of energy allows it to create other elements that we now know in science and in the periodic table. So many of the elements that we know of can be said are birthed from explosions called supernova and are kind of the building blocks of life and are very essential to it. So after death, it's not that it goes away, but there are things that remain even after death. One of them being neutron stars, which are the remnant cores of dead massive stars. So as I said, during a supernova, the star's outer layer is blown out. However, the core still remains, and that core continues to compress into a neutron star. So neutron stars can manifest itself as a pulsar or an X-ray burster. So pulsars are a highly magnetized rotating neutron star that emits beams of electromagnetic radiation out of its magnetic poles. Whereas X-ray bursters are also neutron stars that exhibit periodic X-ray bursts that rapidly increase in luminosity. But a different kind of remnant are actually black holes. So in the case of neutron stars, there are in the category of massive stars are kind of in the lower to medium. However, those in the biggest and largest of the massive stars, their eventual death leads to the creation of black holes. So even larger massive stars, instead of the core forming a neutron star, the remnant is a black hole. And many of you know black holes are points in space that are so dense that they create deep gravity sinks. So beyond a certain region called the event horizon, not even light can escape the powerful tug of a black hole's energy, gravity, and so it does not emit any more light. It eats it up, and that's why are called black holes. Now, the reason I wanted to cover this topic is because I feel like the characteristic of what I call a never-ending cycle is extremely interesting because once a supernova happens and the outer layers of dead stars are blown out, it's not that they disappear. You know, energy doesn't start suddenly and disappear, but they go to other places. So the blown out layers cast material into the cosmos to enrich molecular clouds and become the building blocks of future stars. And I just find this extremely interesting because it kind of reminds me of for me, it's kind of like a fundamental example of the continuous cycle of life and death in our universe. So if you take humans, for example, you know, we are birthed from Mother Earth, and when we die, go back to the soil of our own Earth. And for stars, it's kind of the same. So they are birthed from molecular clouds that are randomly floating around in the galaxy. They suddenly begin to come together, form extremely beautiful entities called stars. And once they die out, it's not that they are gone, but they return back to their molecular cloud states. So I feel like the concept and idea of stars and stuff like that is extremely interesting for me. And so I wanted to share it with all of you guys here today. Thank you very much.